So I'm a systems architect and operations lead at mParticle, and I'm here to tell you a little bit about our experience running Scylla in a production environment for the past year, running one of our mission-critical workloads. I'll tell you a little bit about mParticle, our use case, how we got to Scylla, how we migrated, and what we've done since. So first, a little bit about mParticle. mParticle is a customer data platform for managing mobile applications. We make it easier and more transparent for our customers to manage and control where their data gets sent to third parties. We help them segment that data, enrich it with identity information, and also get a better insight in their customer utilization. Along with that, we also help anyone who uses us improve their application performance overall. We do this all with very strict SLAs. We have near real-time SLAs for all of our customers. We do this processing over 50 billion messages every month. Some of the brands that have trusted our company and our platform are companies like King, Spotify, NBC, Turner. Postmates is one of our customers. They use us to get a better understanding of their own customers' usage of their application. Venmo is another customer who uses us as a unified user profile store and unified data store. So as a whole, our platform can be viewed as a pipeline. We have a couple of main ingestion points that you see here on the left. Platform, which is where data directly from devices comes in, and feeds, which is a server-to-server API implementation that our customers can use to send data directly to us. After that data gets ingested, it passes through a pipeline. It gets enriched with identity information, profile information, rules and filters get applied. The profile, user profile and rules engine is where we currently use Scylla. And after that gets processed, it gets sent out downstream to third parties. All of this throughout our normal operation, we process data for over 350 million iOS devices and 1 billion Android devices, which is in the shape of 50 billion batches or messages every month, which contain 100 billion events and stored as 150 terabytes of raw data. All of this has to stream through our systems in near real time. And when it hits the point of the user profile store and rules engine where Scylla sits, there cannot be any backlog whatsoever. For that, we need to that data store needs to be able to handle the varying rate of data ingestion that we get with very low latency and high availability. On the right here, there are a couple of graphs that represent their metrics from our 2 ingestion points from the past month. As you can see, the rate of ingestion can change from minute to minute, from anywhere from 10, 20,000 messages per second to 30, 40, 50,000 messages per second. And the data store that handles this needs to be able to process this with low latency to satisfy our SLAs. The batches themselves are array of events with some user and some device information that gets processed, and rules get applied to it. When the client application that processes these messages gets one of them, it reads all the historical event information from Scylla, processes it through the rules that the customer has defined, and then writes it back into the Scylla data store. All of this, again, has to be done with very low latency and no backlogs. In addition to the real-time processing, we also have a batch processing mechanism that kicks in whenever a customer makes a change to one of their rules. Whenever that happens, the client application reads all the event data, historical data that we have for the customer, for all the users that the rule change applies to, reprocesses it through the rule, and then writes it back into Scylla and sends it downstream to third parties. Again, that has to be done in very near real time with no backlog. The system, this part of our platform was designed over 4 years ago, and at the time, Cassandra was the best fit for us. So at the time, we looked for a data store that can handle high throughput with low latency, high availability, and Cassandra was the one that fit the bill at the time. It was widely adopted. DataStax had a really good startup program that was lucrative for us, and we adopted it. So the data model is relatively simple. You see a representation of one of our client tables here. Data is split into tables per client, and performance for the first couple of years was great with Cassandra. We didn't have any issues. It was keeping up, low latency, no problems. However, after a short amount of time, we started seeing performance degradation. During our normal operation of our systems, the client application that processes these messages into the data store scales in and out constantly based on different metrics. Some of those metrics are whether or not, obviously, if there's work to be done, whether latency is within reasonable limits, whether the cluster is healthy. And at the time, cluster being healthy was a couple of main metrics were looked at. One, the most important one being pending compactions. Pending compactions were really the biggest thing that was impacting us at the time. And two factors were affecting that. It was the batch processing mechanism that I mentioned earlier that reprocesses all data for users when a customer makes a change, and the server-to-server ingestion in large amounts that customers may send to us. The bottleneck that we were hitting was pending compactions, and whenever one of these two processes would kick in, the Cassandra cluster nodes would start accumulating the pending compactions, which then would in turn increase latency, read and write latency, and then the client application would scale back down, and that would result in backlog in processed data, which would obviously violate our SLAs. So that was about September of last year. We were basically faced with a scalability problem that we needed to solve. One way, obviously, would have been to scale the Cassandra cluster out, which obviously would have been one way to solve it and would have been expensive. Another way was to look for alternatives, to look for something else that might help us fulfill that gap and improve performance. The pain points that we had with the solution at the time was the amount of labor that was involved in tuning Cassandra to make it perform well. Lack of support from DataStax. We tried some consulting firms that ended up being a disaster. And in the end, we just had a performance issue that we needed to fix. One example that will give you an understanding of the scale of the problem was one of our customers used to send us data, and to this day they send us data through our server-to-server integration. They would send us every day they will send us a batch load of data in a span of maybe 2 or 3 hours. They would dump all their data in one shot, and then we would process it as soon as we can. When we first onboarded this client, their data was getting processed pretty quickly, within an hour or two, no issues, just a minor backlog, which they were okay with. However, over time, as their data grew, their adoption grew, and we added more customers to the Cassandra cluster and added more data to it, the processing of their daily load started taking upwards of 18 to 20 hours. Obviously, that was not going to last long. We had to fix this somehow. So we needed to make a choice. And so we decided to give Scylla a try. One of our developers had attended a Scylla summit a few months prior to that point and was very impressed with the product. We had been following Scylla for a while and decided to do a test. The test was relatively simple. We built 2 identically sized clusters, one running the latest version of Cassandra at the time, one running the latest version of Scylla. Then we pulled data for a few of our largest customers out of the live Cassandra database into Scylla, into SQS, and then loaded it with our client application as if it was live traffic into the 2 clusters. We did this multiple times, 4 or 5 times, 4 or 5 iterations of this test, each time tweaking the Cassandra parameters, different parameters to try to make the cluster run better. And in every test, it was glaringly obvious that Scylla was outperforming Cassandra by a wide margin. It wasn't a small percentage of difference. It was absolutely clear to us that Scylla was superior to Cassandra in performance for our workload, for what we needed it. So after a short deliberation, we decided to migrate. We built the permanent cluster that was going to house that data, and we started moving customers over to the Scylla cluster. We moved one customer at a time in a similar manner how we did the test. We would pull the data out of the existing cluster into SQS, load it into the new cluster, and proceed with the next customer. After we were done, came the big moment of realization whether we did the right thing or not. The next day after we finished the migration, the customer that I mentioned earlier in the example started loading started sending their daily load of data. And so we started watching the metrics to see how quickly their data is going to get processed, how much of a backlog there will be, how quickly that backlog is going to get processed. And so we waited for backlog, and we waited, and no backlog. The data that Cassandra a day before was processing in 20 hours, Scylla was now processing in real time. That, to us, was the biggest validation that we could ever want, that we made the right decision, and that Scylla is really much better performing for us than Cassandra. So immediately after we finished the migration, we started looking at even more ways to improve performance of this cluster. We had some even larger customers coming down the sales pipeline, so we needed to make sure that we are as prepared as we can possibly be to handle the new customer load. We made, with the Scylla support engineers' assistance and oversight, we made some schema changes that improved partition key cardinality. We changed compaction strategy, which actually I think later on today there's a talk titled "How to Ruin Your Performance by Choosing the Wrong Compaction Strategy." Definitely recommended to check that out. So we changed a few things and got ready for the new customers. Currently, our volume is over 3 times larger than it was a year ago. We're running a 10-node 16XL cluster in Amazon, and I'll touch back on the hardware in a moment. But the most important thing is that we don't have compaction backlogs, we don't have high latency, and we don't have backlogs. The lack of compactions impacting latency is what is making the whole experience much smoother and much nicer. The fact that Scylla isolates compactions and other tasks into background and foreground tasks and automatically tunes its performance to perform at the optimal level is what makes the cluster perform as well as it does. From the moment that the application is installed on the hardware until it starts getting production load, it is tuned simply by itself without having any human intervention to perform it at its peak performance levels. So back to the nodes. We started, originally when we did the migration, we started with I2 nodes, which is what was running the Cassandra cluster at the time. And they were great. They were perfect for the job, great I/O, local storage, lots of memory. A couple of months later, in March of this year, Amazon announced the availability of the successor of the I2, the I3 instances, which offer even better I/O, more storage, they're cheaper. So needless to say, we were very intrigued, and we decided to move to upgrade the cluster to those nodes. We upgraded literally we started upgrading literally the day after Amazon announced the availability of I3s in our region, which we took the risk, obviously, with anything being this new, we took the risk of issues. And being on the bleeding edge has its pain points. It's not called a bleeding edge for no reason. As soon as we started migrating nodes, we started noticing issues. There were obviously the kernel wasn't able to support the i3s at the time. It was just too new of a hardware. So we had issues like the instances would drop off the network. Hard drives would just poof and disappear from under the OS and just not be available. So we switched kernels, we upgraded drivers, stabilized the systems. So for the next month and a half or so, we were just facing issues of underlying hardware stability. The underlying hardware instances were apparently also not stable enough to handle production workload, but the fast recovery time of Scylla streaming data from other nodes, in addition to the actual hardware being screamingly fast, made those issues tolerable. And of course, I don't recommend anyone jump into upgrading to something this new that quickly, unless they're prepared to accept the risks. But the combination of good hardware and Scylla's capabilities to stream the data quickly made the recovery of nodes that were randomly dropping off the network very quick, and we would restream a few terabytes of data in a couple hours, and we would be back online. Also, one note about our cluster size, we picked a small number of large instances for a couple of reasons. One, with less number of instances, you're less likely to get hit by the cloudiness of Amazon, and I'm assuming all other providers as well, where underlying hardware has issues and instances have problems and have to be stop-started to get to a new hardware. The less instances you have, the less chance you have of getting hit by one of those. The other thing is having large instances or large VMs gives you the chance of either being the largest or the only VM on a physical host. For that reason, you end up having less chance of being affected by a noisy neighbor. So the bigger you are, the better you are, the better off you are. Lastly, I wanted to touch on support. In my career, I've had the pleasure or misfortune of dealing with different support different organizations' support teams. In most cases, what I like to see, what I hope to see from a support team is real good understanding of their own application and software, whatever the case might be. Really good understanding of the underlying infrastructure that they run on, whether it's the OS by itself or OS and network, whatever they are using, they should be understanding well. And lastly, dedication to help you and professionalism. In most cases, with most support teams, you end up getting 2 out of the 3. With Scylla's support team, you get all 3 at 100%. And cliches like giving 110% or going the extra mile just don't do them justice. These guys are absolute professionals, and they're fully competent and in their product itself, into the underlying infrastructure. They know how to tune their application and the OS to the point that they squeezed every little bit of performance out of your cluster before you even start using it. That, coupled with the fierce dependability and dedication to help you and to get you to your best possible level, make the difference between a customer that is content or even happy with a product and one that is ecstatic about your product and you've won them for life. So I cannot praise them any more than I have. And I have to say, they're probably one of the biggest reasons why we were so comfortable migrating to Scylla, because they helped us along the way when we were doing the testing, the migrations, and ever since then we've gotten nothing but outstanding support from them. So this is our story. We are a mobile data company that used to use Cassandra. We moved to Scylla for better performance, better quality of life for our engineers, and awesome support. We are planning on expanding into multiple regions, and we'll take Scylla with us. And if you are in the market for a NoSQL database or are struggling with Cassandra, definitely give them a shot. Give them a shout and check them out. You'll not be disappointed. If you have any questions, floor is yours. If not, if you think of something else later, my contact information is here, and the slides will be up on SlideShare later, so you guys can get in touch. Thank you.